Hi, I'm Lindsey.
And I'm Connor.
And I promise this is interesting.
I sure hope it is.
You've never expressed doubt in me before. God, now there really is pressure. Connor,
They've always been interesting at this point.
how are you doing today?
I'm doing fine.
You're doing great.
A little warm. It's a little warm in this room.
It is a little bit warm, which has me a little bit concerned how we're going to fare in the summer because it's relatively early in the spring.
Oh boy, yeah, that's true.
Right now.
That's true.
So, but that's a problem for another day. Connor, where do you think we're going today? Do you have any idea?
Your last hint was big.
Yes.
And I guessed elephant, and you said no.
Yeah.
I
stand by that.
I have no idea where we're going today based on just that hint alone.
Incredible. Today. Do you remember when your hair was sticking up in the last episode?
I think you do.
I don't know why. That has really been tickling me. Okay, anyway. Today we're going to be discussing the void of space.
Oh.
Specifically, the Boötes void. All right.
Say that word again for me.
Boötes. We're going to get there.
Can you spell it for me?
Bootes. I want to call Boötes so bad, but that's not how it's pronounced. It comes from the Greek word Boötes, which means ploughman, because it's part of the Boötes constellation. Okay. Anyway, it doesn't matter. We're going to talk about it in a minute.
Okay.
I'd like to open this episode with the song Space Oddity by David Bowie, but his estate never got back to me, so that might be out of the budget. So just imagine that it's playing right now. I, like any other red-blooded American child who visited the space station at Cape Canaveral, wanted to be an astronomer for exactly 0.2 seconds. But when I realized the job was not about staring at stars and just going, ooh, that's pretty, and actually involved very complex math, I had to jump ship.
Yeah.
And go back to miming.
Yeah, that is the unfortunate thing about astronomy.
Yeah, there's a lot of math and science involved, as we're going to learn today. Still, astronomy, Carl Sagan, and NASA sweatshirts have been hobby-level interests of mine for a long time. And today I'd like to plunge us all into the void. I'm talking about the Boötes void, the most haunting place in the known universe. Do you know anything about the Boötes void?
I don't even know how to spell it, and you already spelled it for me.
There's an umlaut over that second O. That's why we say Boötes. Yes. So the Boötes void, otherwise known as the Great Nothing, a.k.a. the Wayne Gretzky of the sky, is an eerily empty patch of space.
Why are you taking shots at Wayne Gretzky?
I'm not. Just he's known as the Great One.
Oh,
and this is called the Great Nothing. I guess Wayne Gretzky was so good that they were like, we can't even give him a cool nickname because it's going to diminish it.
Yeah.
It's the same thing with the Great Nothing. Because it is ginormous, I think that's the cosmological term, sitting pretty at a whopping 330 million light years across.
Oh, wow.
Which means if we need to brush up our 7th grade science, like I definitely did,
okay,
it takes light, that instant thing that we all see all the time, 330 million years to travel across the whole thing.
Wow.
That's what my community calls a big back. For comparison, our adorable little Milky Way galaxy is about 100,000 light years across.
Oh, we don't even reach like the millions.
No. In a space that colossal, scientists expect to see a couple of thousand galaxies floating around. The Boötes void has about 60. That is how empty it is.
That's a lot of space in between space.
A lot of space in space, yeah. So why? That is the question resting at the center of that big, fat, bald patch in the sky. Why is the Boötes void so empty? Did an alien race vacuum out all the stuff that used to be in there? Was there a star war? Did God forget? These are the questions that I think NASA is probably asking, and these are the questions I'm going to answer today.
Now, you'll probably get into this, but is there like a very clear border of the Boötes void? Like, is there a clear like stop and start?
No, I mean, we're going to throw up a map of like the known universe.
Okay.
And it's going to help visualize some of this. So I realize this is a podcast. I'm going to do my best to explain all of this so that our listeners can understand. But on YouTube, it'll be easier because we can throw up some photos and we can really visualize just how giant this void is.
Sure.
And how weird it is that it's there.
I'm just thinking about like our solar system is very clear. We have the sun at the center, and then like it goes all the way out to like Pluto.
Right.
And that's
depending on who you ask. See, the border is not that clear.
Yeah, I guess
space is space.
Fair enough.
Here's the theme of the day. We don't know.
Okay.
It depends. That is like really, I think that should be the conscription above NASA's door. Like, it depends. Do we know the answer to these questions? Kind of.
Kind of, yeah.
We kind of know this. And next year, when we get more information, it's probably going to change. And that's what I love about science, baby. Now, to understand just how strange and uncanny the Boötes void is, I did some research into how the universe is built. Because much to my surprise, there is some semblance of structure to the universe.
Okay.
I thought we were living in like a cosmic Jackson Pollock painting.
Right.
But there is some real slapshod, spooky scaffolding involved, actually. So, we live on Earth, which I used to have a photo of Earth on my wall and it fell off a couple days ago, which I'm taking as not an omen. But we live on Earth. Earth is one planet in our solar system. Mm-hmm. Okay. Our solar system is one of about 3,200 in the Milky Way galaxy.
Okay.
Now, galaxies are clusters of solids and gases, and most of them have a supermassive black hole at the center that everything revolves around.
Right. And a solar system is typically a star in the center with things floating around that star.
It is a system based around a star.
Yeah.
Exactly. So, we have reached the end of my Texan middle school knowledge of space. That's where it ended. It ended with the Milky Way.
Right.
And when we asked, is there other stuff out there? They said yes.
Exactly. How much stuff? So much stuff.
Where is it? All around. What's it made of?
Stuff.
There's gas and dust, we think.
A lot of gas.
Yeah.
Why is there so much gas in space?
A lot of gas
That
in
seems to be
space.
a thing of the conversation. It's like
We are going to talk about that.
gas clouds.
Yeah.
And
Why is it so farty up there? I don't know. We actually do kind of know, we think. It depends. What I didn't know was that galaxies themselves cluster together. So
Interesting.
the clusters cluster. Just like in high school when all the dancers dated all the musicians and the theater kids dated each other and the art kids dated nobody. Everybody clusters together.
I imagine it's like a gravity thing. Like there's
Yes.
Yeah.
So we're also going to jump into that. Galaxies cluster together due to gravity and the presence of dark matter.
Ooh.
Dark matter is a quiet obsession of mine.
Is it really?
I need everyone in Los Angeles to know that when I am driving 75 miles an hour in my red Corolla down the 101, dark matter is what I'm thinking about.
You've never mentioned dark matter. It's been a very quiet obsession.
I am obsessed with dark matter. That is the most interesting thing to me. I cannot believe we're not talking about it all the time. It should be this and the Terra Nova expedition. That's all I ever want to talk about. Dark matter. What is dark matter? It's stuff. It's invisible to us, largely undetectable stuff. We only know it's there because of everything around it.
Right.
It's like when wind blows through your hair, you can't see the wind, but your hair wouldn't be doing all of that if there weren't something there.
Right.
That is dark matter. It works the same way. So think about galaxies, right? They're spinning all the time, very quickly. Based on everything we know about physics, math, and inertia, stars at the outer edges should be flying off like raindrops from a spinning umbrella.
Right.
Right?
Because the level of momentum that they're building up and stuff. Yeah.
Exactly. It's like at those little playground rides. We're going to have to throw a picture up because I don't know what they're called. But
merry-go-round.
like you spin
Yeah.
around. If you let go, you fly off.
Right.
Stars should be doing that
Yeah.
all the time, and they don't.
I mean, that's a physics experiment they show you in high school. Right?
Exactly.
Yeah.
Yes. So that means there must be something else around the galaxy and inside of it that adds an extra layer of gravity, holding everything together.
Almost like a net.
Yes,
Yeah.
that is dark matter.
Interesting.
Now, why can't we see it or detect it directly? Because it isn't made of atoms. Like, literally everything we know about. Isn't that crazy? You're not
atoms-
freaking out about this. I freaked out
No,
when I read that.
I'm freaking out about it.
This is
I'm
Connor
having-
freaking out.
I'm having
He's so
trouble
calm.
understanding. What do you mean it's not made? What is it made out of?
We
How is it
don't
not made
know.
out of atoms?
We don't
That's
know.
like the basic thing. That's the basic Lego of life.
Everything we know is made up of atoms. It is the building block of life and not life.
Right.
So what do you mean it's not made of atoms? But everything we know about is not saying very much. Only 5% of the universe is made up of the normal stuff we can see and touch. It's made up of atoms. Water, foxes, each other, atoms, atoms, atoms.
Right.
About 27% of the universe, though, is made up of dark matter. The rest of it, entirely invisible and undetectable and unknown by us. We don't know.
You said 27%
Dark matter.
dark matter.
Yes.
Wow.
5% regular matter that we kind of understand.
that we can map out and look at.
Yes.
Yeah. That's crazy. I don't even know how to think through what you just said. Only 5% of the universe is stuff that we know about.
Yes. I don't even know how to feel about that. I don't know how I'm feeling. Anyway, so that's that. Okay, and we're going to tie back into dark energy and dark matter in a minute. But I wanted to lay that foundation. It's very important to understand how the Boötes void exists and why it's weird. But we can't know how weird it is if we don't know how the universe works, which apparently I don't. So back to space clusters real quick, which sounds like an awesome name for a milk chocolate. The Milky Way is part of the Virgo cluster, which is unfortunate because Virgos are the fucking worst. Now, what do these clusters of clusters do? Because remember, galaxies are clusters of gas and dust and other things, and they cluster together with other galaxies. So what do these galaxy clusters do? They cluster together as well into something we call superclusters.
Interesting. So
yeah,
and I'm sure there's something poetic about this, and some scientists feel this way. That kind of sounds like how human bodies work, where cells, atoms make up cells. Cells will cluster together, make tissue. Tissue clusters together to make organs, like that kind of thing. And it's an infinitely scalable thing. Right?
I'm of the belief that every answer to any question you could ever ask is in nature.
Yeah.
How do you want to package something in a biodegradable way? You have to find a way to put skin on it because like apples have skin. That's its packaging.
Right.
Oranges have peels. That's its packaging.
Have you ever seen in grocery stores sometimes where they'll put like bananas in plastic?
Dude.
Or like oranges in a plastic bin.
Or like hard-boiled eggs in plastic. I'm like, it had the thing. It had a box. It's called the shell. We could just use that.
Right.
Drives me crazy. Yeah. So just to recap, our cluster, the Milky Way, is part of the larger Virgo cluster of other galaxies, which is part of the Laniakea supercluster. Laniakea, which is a word I'm sure I'm pronouncing exactly correctly. It's a Hawaiian word, which means immeasurable heaven, which
That's
I
very
love.
pretty.
That's
very pretty.
That will be the name of my first dog. So, for sure. The best way I can describe it is we are living on a slab of Swiss cheese. We're in a hole. There's another hole over there. And the holes are generally kind of close to each other. That's like the easiest way because the distances we're talking about are actually
immeasurable.
Yeah. We can never actually fully fathom.
Yeah. And again, I just want to clarify for my own brain. You're saying that the Milky Way is a part of one of these clusters.
Yes.
Wow. Okay.
Yeah. We're in a cluster of galaxies.
Right.
And we're also in a supercluster. So if you look at a map of the known universe, which I'm going to throw up, you'll see these superclusters spread out across the blanket of space and time.
Okay.
You will also notice 3 massive voids in between these superclusters. There is some stuff in the void. There's some stars, there's some planets. It does not look normal. They look like giant holes in the fabric of space. So the Boötes void is far and away the biggest one. So if Boötes is Gretzky, then I have the Capricornus as like Mario Lemieux, and then the sculptor void is like Pierre Pilote or whatever.
I'm really proud of you for getting into hockey and knowing all these people. We're watching playoff hockey right now.
Yes, I have a new hobby, which means I'm obsessed.
And who's your favorite team? Who do you want to win the Stanley Cup?
I'm going for the Edmonton Oilers.
The Edmonton Oilers.
I love the Oilers.
Gotta love that Connor McDavid. Yeah.
I really do. Beautiful skater. That's what sold me. I'm like I'm kind of gay about it. I'm like, God, he's such a beautiful skater. Just want that boy to win. Go McJesus. I like this guy. Connor. His name's Connor. I'm sold. Tell me nothing more. So anywho, as far as why the Boötes void is so voidalicious, we don't know for sure. One theory is it could be the result of multiple smaller voids merging together over time.
Okay.
Another theory suggests it's just some ultra rare anomaly, like with how absolutely enormous and immeasurable spaces, some weird empty spots were bound to pop up.
And how much time has passed, right? It's like,
yeah.
What's that theory? If you put 1 million monkeys on typewriters, eventually they would write Shakespeare.
Right.
You know,
a broken clock is right twice a day and all that stuff. One cupcake's going to stick. So,
stuff just kind of happens. Yeah.
Yeah. It could be some ultra rare anomaly, which is caused by quantum fluctuations dating back to the early days of the birth of the universe, post Big Bang, and all, the math. So, and of course, some people think it has to do with the multiverse.
It always goes back to multiverse theory, doesn't it?
I
Wormholes and multiverses.
hope that there are not multiple universes.
Okay. Why?
This one's enough. I'm battling lawn equipment. You know what I mean? I'm beefing with my neighbor because he just bought a gas-powered leaf blower.
He did.
And I'm like, what is wrong with a rake? What happened to the broom? Like, did we need to evolve past that? I don't need another universe of other people with problems and noises and smallpox. I don't need new smallpox.
There would definitely be new smallpox in the multiverse.
That's how I feel. So I just keep it zipped. If there's a zipper, let's just keep that one closed, guys.
There's a great short story by Ted Chiang.
Ooh.
Yeah, who wrote, if you don't know, he wrote the short story that eventually became the movie Arrival.
Yes. Beautiful writer.
Beautiful writer. And he's mostly written short stories. I don't think he's actually written a full novel.
I don't think so.
But one of the short stories he wrote that I thought was really fascinating was somebody invented a box to where you could connect and talk to your multiverse self. And the story follows a therapy group that exists from people who their multiverse self in the different universe is like way more successful than they are. And it's like a kind of an AA meeting of like, yeah, I'm just really bummed because like my multiverse self is a rock star and I'm a loser.
I'm a screenwriter. I get rejected constantly. One time I walked out of a job interview and I immediately got an email stating we've decided to go with another candidate. And literally within 10 seconds, I got another email that said one of my pieces had been rejected by a literary magazine.
Oh man,
it's like
that's tough.
Typical afternoon. Tough. Like I don't need to meet her. If she's doing better, good. If she's doing worse, good. Like either way, I'm not even rooting for me. I don't need more people over here. There's enough going on. Another theory is that a different universe collided with this universe. And that erased some key structure in the process.
Interesting. Okay. Yeah. So we have multiverse, which people think it could be related to that in some way, where it's like maybe holes to a different version of us.
Yeah.
Of time.
That kind of thing.
And you're saying this one is like our universe, everything that we know, collided with another everything that we don't know and made some holes in the fabric.
Yes. A more Tom Cruise approved theory is that trillions of years ago, which the universe is not even that old, so here we go, but trillions of years ago, the Boötes void was full of galaxies and some distant space creature has since harvested them all.
Interesting. Like oh gosh, who's the character? Galactus.
Who?
Galactus. I'll throw up a picture. He's a supervillain from Marvel Comics. And he's a supervillain, not because he's like super conniving and smart. He's massive and he floats through the universe and eats planets. And the whole thing is they have to stop him. He's a Fantastic Four villain.
Oh boy.
That's where the Silver Surfer comes from. Silver Surfer comes to planets and goes, hey, by the way, Galactus is coming and he's going to feed on your planet. Get going.
I'm kind of scared of the Silver Surfer.
You should be.
If I'm being very honest.
You should be.
That character's always really spooked me out. I don't like that. Like if I woke up in the middle of the night and the Silver Surfer was in my room, I would never be the same.
I mean, that's the reaction you're supposed to have because he is the harbinger of things to come, which is a giant man with a top hat, essentially, a purple top hat, who floats through the universe and eats planets in one bite. Is that theory on your paper?
It's not, weirdly. I missed that when I was on nasa.org.
Yeah.
Speaking of, wanted to go on this tangent for a second.
Okay.
Have you heard of the Star Wars theory of the universe?
Like that Star Wars is accurate?
Not exactly.
Not exactly. But like long, long ago in a galaxy far, far away.
Yeah.
That we used to be super advanced and have laser swords and spaceships.
Yes. We used to live in a universe that was more well connected. Going, intergalactic travel was like going from one suburb to another.
Right.
We were very advanced and connected, but then war broke out and we essentially nuclear wasted ourselves.
Yeah.
And that's why space is so empty. And we're just the first life forms to come back.
Yes, I've heard theories like that. I know there are some religions, I won't say specifically who they are so that we don't get targeted by them, but if you know, you know, who also use that as part of their religion. They're very famous in Los Angeles. I'm sure you know who I'm talking about.
Yes, I do. You want me to say it? I'll say it. I'm not afraid. I want to commit crimes. That's what I'm here for.
You did say you wanted to commit crimes in the last
Can
episode.
I tell you a story about the Scientologists?
Please.
So I was living in New York. I was a broke college student.
Okay.
My boyfriend and I had just broken up. Life was bad. We had mold in the bathroom. I was living with how many roommates? 4. There was a couple in the bedroom right next to mine.
Okay.
And they were fine. They were very quiet. They were up late at night. The TV was always on. But truly didn't know a thing about them.
Okay.
But I don't think they worked because they were home all the time.
All the time.
And
yeah.
they weren't on work meetings, like, oh yeah, George, I'll send you that email. There was none of that going on.
They weren't working from home. They just didn't work.
I think they were just making sourdough bread and they're like, I think they were just making out, whatever.
Yeah.
But one day I come home and there's a letter on the fridge that says, hey, we left. A new guy is going to be moving in. So no worries. And my other roommates and I were like, what? Did they say anything? They didn't say a word to any of us. They literally packed up their room in the middle of the night and left when nobody else was home.
That's crazy.
And then this new guy moved in, was great, by the way, amazing.
Oh,
roommate.
good.
Love this guy. So that worked out.
I thought you said he was going to be a Scientologist.
No, thank God. But a few weeks after they left, we started getting mail from the Church of Scientology. And they were addressed to that couple.
The couple, yeah.
And they were saying, hey, we're going to send you a VCR and a tape. And we think you should watch this tape just to remind yourself why you joined us in the first place. John. Always signed just a first name.
John.
No last name.
Interesting.
No return address. Just wanted to gently circle back to this conversation and let you know that we're thinking of you. And we hope everything's just beautiful there in New York.
That's freaky.
Yeah.
I don't like that.
One of my roommates watched the tape and she was like, I am spooked. And she burned it on the beach.
You never watched it?
No. I was like, I don't want to know. I was very in my angry atheist phase still at this point. Again, post breakup, I was like, God's not real. He has forsaken me, whatever.
Yeah.
So I didn't watch it. But we kept getting mail from them for a long time. And we found out a couple years later that they moved to Clearwater, Florida.
Oh.
Where the Church of Scientology has basically taken over the town.
Okay.
So I don't know why they were sending us mail like they had tried to escape the church. They clearly left to go be more in the church.
Right.
So, but that's my relationship with Scientology. Anywho, so the Star Wars theory is a very popular, well, I won't say very popular. A couple of people believe in the Star Wars theory.
It's fun. It's fun
I
to
like
believe
thinking
in.
about it.
Yeah.
That's a fun idea.
Because it doesn't hurt. It doesn't hurt anybody to think, oh yeah, the universe is so old. Maybe we used to be really advanced, right?
Yeah. Or also like, why is it so empty and quiet out there?
Right.
Like, are we really alone? That seems super unlikely.
I know you're reading off of your theories. You haven't read the 3-body problem, right?
No.
Are you familiar with the theory of the 3-body problem and like the dark forest, the dark forest theory of the universe?
No.
Of like why we haven't contacted or been contacted by other species?
These are all new words to me.
So in the 3-body problem, I think in book 2 called The Dark Forest, they say that the reason that we have not met any other species or any other like life forms in the universe is because everyone's scared of each other, right?
Yeah.
Because the truth, there's a fact about of living, of life, and is that if you have a culture, the culture must expand. And if there is land, the culture will take over the land. And if there is a culture existing on that land already, then the culture taking the land will kill that culture, right? Or kill those people. And so everybody in the universe, that there are multiple species in the universe, but everybody in the universe is trying to hide as well as possible from being seen by the other cultures or species. Because the only logical response to another species existing is to destroy them immediately before they see you.
Yeah. We've knocked out other species of humanoids before.
Easily.
That's probably not the correct word. But other bipedal
I don't think you're offending
apes.
anybody by saying humanoids.
Well, I don't, it's not like exactly. It sounds like I'm talking about robots or something.
Yeah,
but like
you're right. Yeah.
Neanderthals, why are there no Neanderthals? We, the Homo sapiens, murdered them.
Exactly.
We bred with some of them, but we murdered them, and that's why they're not around anymore. There was also another species of human that had like larger heads, and they were very small. They kind of looked like little aliens, and we killed them too. We're the only bipedal apes left.
Yeah, there's we're Homo sapiens. We had Homo erectus,
Yeah.
Homo habilis, all these different sapient
Yeah.
creatures, right?
Evolution branches out. Like that's why you have different types of monkey.
Yeah.
Like evolution is highly specialized. So this one monkey can swing by its tail better than any other monkey. And this monkey eats more meat. And this monkey is really good at hunting.
Right.
And that's why you have different kinds of monkeys. So we used to have different kinds of human.
Yeah.
And those people aren't around anymore. That's not a coincidence. We did that on
It's
purpose.
not, and that's the thing. That's the dark forest theory is that all species have to expand and there's a finite amount of space.
It's a very upsetting and disheartening thing too, because if I could get to another planet and discover a new type of crab or find like some kind of intergalactic type of fox, I would be over the moon. I'd be so excited to spend time with that creature.
I know you
just want to take pictures.
Yeah.
I want to hang out. I want to put it in a little test tube and just see what happens. Like I want to hang out with it.
Right.
But other people would ruin it.
They would. And that's the dark forest theory is that the universe is a dark forest and everybody's trying to stay hidden. And anytime anybody else sees another species wandering through the dark forest, they have to shoot them.
Yeah, well, we're not doing a very good job of staying hidden.
No, we're not. We blast out our location as much as we possibly can.
We do. We're going to talk about that in a minute as well.
Oh, boy.
So the most promising areas for life in our knowable universe as of right now include Europa, which is Jupiter's smallest moon.
Okay.
It has a very smooth surface, which makes it look very youthful. It has a great skincare routine, you could say, which could indicate that there's an ocean beneath the frozen surface. We think this because this is amazing. I love this. Europa is impacted by Jupiter's gravitational pull. Jupiter's gravitational pull, despite its enormous size, is only about 2 times stronger than Earth's gravitational pull because Jupiter's a gas giant. So it's all fart, and we got land and rock and stuff here, so we're stronger.
Exactly.
But it's affected by Jupiter's gravitational pull, and that's what keeps it in orbit, right? Because of this pull, Europa's icy shell gets stretched and then released and stretched and released.
Oh, interesting.
It's called, what is it called? It's called tidal flexing. And it generates heat. It generates actually so much heat that we think it's melting some of that icy shell.
Really?
Which is creating an underground water, like an underground salty ocean, which could theoretically support life that we would recognize.
That's so fascinating.
Right. It's probably not little tiny green aliens in a submarine, like conducting experiments and going into Ocean Gate and trying to get to the Titanic. But it's probably some single-celled organisms, which might be interesting. Maybe an octopus.
The key thing is that they can support life. Like that is really the thing.
Yeah. We're just looking for ways. But the more that I'm learning about this, the more I'm like, we just don't understand the basics of the universe. If we only understand 5% of all matter that's out there, there's probably life all around us, and we just can't detect it.
Yeah, I got it. So you and I work in the film industry.
Yes.
Right?
Unfortunately.
Yeah. I worked on one of the first movies I ever worked on. I got the pleasure of driving around Lance Reddick. Shout out to Lance Reddick. He passed away a couple of years ago. A wonderful actor. Brilliant. And we got into conversations about Star Trek and interdimensional species and things like that. He was a big Star Trek Voyager fan, of all things. And he was telling me about this interview he heard with Neil deGrasse Tyson, where he basically talked about it's like there's a difference. We are carbon-based life forms. That's what humans are. Everything we know are carbon-based. Cats, humans, toads, all based in carbon, right? But what does another elemental life form look like, right? That we can't even fathom that because it's so outside of our realm of understanding.
Right.
But there's in a universe of infinite possibilities, what does a helium-based life form look like if we're carbon, right? So anyway, I just thought that was really interesting. And I think about that conversation every now and then.
It's very interesting. And it simultaneously makes me feel very alone and very not alone. Carl Sagan said, "The universe is a pretty big place. If it's just us, seems like an awful waste of space." I think I might get a quote of his tattooed on my body. I'm a big Carl Sagan fan.
He's fantastic.
Maybe I'll get a tattoo on my ass. Although having "We Are Made of Star" stuff on my rib cage is like trashy. A little New York slam poetry scene for me. So we'll figure it out. So we're not entirely certain. All of this is to say, we don't know what created the Boötes void or what secrets it may hold to other aspects of life or not life in the universe. And we're not entirely certain that we're alone in the universe. In fact, given how much space is in space, it's pretty likely that we are not actually alone.
Statistically, right?
Right. We are likely in company with some single-celled organisms, maybe some kind of algae, an octopus with a hat on, something fun.
Well, you got to think. I don't want to interrupt you. I'm sorry, but
no, you're good.
imagine exploring our planet, and you only explore 5% of the planet, right?
Yeah.
Depending on where you start, that could make a huge difference.
Yeah. What if you only looked at 5% of like the Amundsen Sea and you
Right.
were like, that's planet Earth?
Or you went to the Dead Sea, and it's like, we discovered all of that. No life in there.
So specific
Yeah.
to that area of the
Exactly.
world. Yeah. You're missing so much information. But while we're floating around in this big empty chest cavity that is our world, let's talk about some other things we kind of know about and kind of don't. The Methusaleh star.
Ooh, I like that name.
Are you familiar with the Methusaleh star?
I'm not.
Are you familiar with the name Methusaleh?
Is that a Greek legend? Greek
No.
myth?
Our Bible
Yes.
audience might recognize that name.
Yes, that's right.
Methuselah is a biblical character who lived to be about 1,000 years old.
Right.
So the Methusaleh star is very, very old, like still watches All in the Family on a thick-ass TV. Old. We can tell it's over the hill because it's made up mostly of hydrogen and helium and has very little iron, which means that it came into being at a time when hydrogen and helium dominated the universe. Because iron and all the heavier elements are made in the core of stars, but at the very beginning of the universe, we didn't have a lot of those. So that's how we know. Some very complex math that I can't do puts it at around 15 billion years old.
With a B.
Yeah. That's pretty old. Older, in fact, than the universe.
What?
The universe is estimated to be about 13 billion years old.
Oh,
So how is that possible? How does that happen?
I don't know.
What's going on there?
that's crazy.
Our star, our own star, the sun, for example, is like 4 billion years old, by the way. So that tells you just how old.
Interesting. Okay.
So to accurately age the universe is a pretty steep mission. So they call them error bars. They're quite wide ranging.
I imagine they'd have to be.
Yeah.
Because like if you were a scientist trying to measure the age of the universe, you would think that you would just go off of the oldest thing you can find, right? That would be my thought. It's like,
Kind
okay,
of,
the oldest
yeah.
thing in this thing must be the age of the thing.
Yeah, but also again, we're going off of what we can detect, which
Right.
we're learning is very, very little.
It's very little, yeah.
So I could theorize that something is 12 billion years old. And if we actually find out that it's 800 million years younger than that, my estimate would still be considered good.
Okay, so there's some room for error.
Yeah,
It's
like you can't expect me to get like the universe was born in the autumn of 2001. Like you can't get that specific
exactly.
yet.
It's
We're
like
not
in
there.
math class when they tell you with decimals. It's like, okay, just round up if it's at 0.5.
Exactly.
Yeah.
Yeah. Or if you get close enough to the answer, we'll give it to you.
Right.
That's what my teacher did because I was really dumb and I just wanted to graduate from high school. So because in space the margins are so wide, distances so unimaginably long, to get an exact number for anything is next to impossible.
Yeah,
All we can
of
do is all we
course.
can do.
Of course. That's the thing. Estimates are kind of scientifically acceptable.
They are.
Yeah.
Gets us there, gets us to the next step. Why not?
Right.
But of all the estimates concerning Methuselah's age require us to push those error bars to the absolute maximum capacity. So that means this star was either created smack dab at the beginning of the universe, like it was born from the Big Bang,
Right.
or the universe is older than we think it is. Physicist Robert Matthews of Aston University, which is in Birmingham,
Okay.
UK, which is where the Peaky Blinders were, fun fact. He says, I quote, I suspect that the observational cosmologists have missed something that creates this paradox, rather than the stellar astrophysicists. That's not because the cosmologists are in any way sloppier, but because the age determination of the universe is subject to more and arguably trickier observational and theoretical uncertainties than that of stars, which makes sense to me. With a star, you're dealing with a singular object. When
Right.
you're dealing with the universe, you're dealing with
All of them.
all of that.
Yeah.
95% of which you cannot see, apparently.
You can tell how old a tree is. It's a lot harder to tell how old the forest is.
Exactly.
Yeah.
Exactly. That's a really good analogy.
Thank you.
But what could be making the universe potentially appear younger than this particular star? He says, there are two options. And the history of science suggests that in such cases, the reality is likely a mix of both. In this case, that would be sources of observational error that haven't been fully understood. Totally plausible. Plus, some gaps in the theory of the dynamics of the universe, such as the strength of dark energy, which has been the prime driver of the cosmic expansion for many billions of years now.
Huh.
And I said, what's dark energy?
So you're saying dark energy, which is not the same as dark
It
matter.
is not the same as dark matter.
There's a new dark thing. New
Now-
dark thing just dropped.
We're going to talk about dark energy.
Oh boy, I'm excited.
Now,
This is sci-fi stuff.
we've been talking about the universe. We talked about dark matter, planets, stars. So try to visualize all of this in open space.
Okay.
Are things moving closer together or are they moving farther apart?
Now, I'm going to cheat because this is a question that my science teachers across time always pose to us, which is the universe is expanding, but where does it expanding to? Is it moving farther apart? Is that right?
Yes.
Okay.
The universe is expanding. Now, in the context of the Big Bang Theory, this makes sense, right?
Yeah.
A tremendous explosion pushes everything out
Explosions go out.
far away from each other, and all that force and energy is supported by inertia, which is sort of the opposite of gravity, right? Things just want to keep moving the way that they're moving. This is why George Clooney floated away from Sandra Bullock. This is why I don't leave my house very much. We just want to keep doing exactly what we're doing.
Right.
It's also rational to think that at some point that energy would run out and gravity would pull everything back together, especially when you consider the mass and density of some of the objects in space, like black holes, supermassive black holes,
Right.
dying stars, supernovas. All of this should bring us back together into essentially an atom-sized teaspoon of everything in the known universe. That is called the Big Crunch. It's a theory. And the universe would just continue squeezing together and exploding apart like a big, thick, rocky heart. Right?
Right.
That would make sense. This is what we thought might happen until the late 90s, when scientists discovered that the universe is not, in fact, slowing down. It is speeding up.
It's speeding up.
Yes. The only explanation we've come up with so far is some mysterious force is counteracting gravity and pushing everything apart faster and faster. That is what dark energy is.
So it's a mysterious, unseen energy that's causing the universe to speed up around us.
Yeah. Because with everything we know about gravity and inertia, that doesn't make sense.
Right.
So it's an
Right.
entirely separate force.
Because and the law of energy conservation, right? Something at rest is going to stay at rest. Something in motion will tend to stay in motion.
Exactly. Yeah.
That kind of thing. But that only happens in a vacuum. If you push a ball, it won't roll forever because of outside effects like gravity
Right.
and friction.
Exactly.
and
You're pushing
inertia.
against the fabric of space and time.
Right.
That will eventually slow you down. It'll take a long time.
I would hope so.
But it'll slow you down.
Yeah. But we're saying we're speeding up.
Yes.
Wow.
So you can think of it like, okay, let me explain this. So that unknowable energy is what we call dark energy.
Okay.
And the more space that is in between things, the more that energy multiplies. So you can think of it like a piece of paper with
yeah.
a fan underneath it.
Okay.
Now imagine that it's pushing up, right?
Sure.
But also there's some energy pushing things down. You're
Right.
seeing this part like droop. So there's like this way, and it's also going this way. And then those two forces are working against each other. But what's interesting is that dark energy doesn't thin out as the universe expands. It keeps its same density, as it were. Now you got to think, right? Stay with me here. Gravity, when you get farther and farther away from the Earth, you stop getting pulled in by its gravitational pull.
Right. It gets weaker.
Right. The moon is actually drifting a little farther away from us every year because it's drifting a little bit farther. Earth's gravity is just not keeping it in the exact same orbit. But dark energy doesn't do that. It actually gets stronger
Interesting.
in the vacuum.
It's like an inversion of gravity, I guess.
Yes. That means over time, dark energy will become more and more dominant, and eventually it'll overpower everything, even gravity. And that could lead us to the big rip.
Not the big crunch, the big rip.
Big rip. Now, how would that go down? Galaxies would separate. First, galaxies would be too far away to see. We'd be all alone in some dark, dusty corner of the attic with no visible celestial neighbors.
So the clusters are breaking apart at this
Yeah,
point.
everything would drift so far apart that we would think we are truly alone in this big black void. And then solar systems themselves would unbind because gravity won't be strong enough to hold stars and planets together. So wave goodbye to the whole planetary family. Planets then would tear apart. Earth is a water-stained telegram in the wind at this point. And then atoms would unravel. In the final moments of noble existence, the fabric of matter itself comes undone, like a big bag of yarn, left alone with some kittens and a 2-year-old.
What does an atom become if it's unwound?
A bomb? I don't know. Ask Oppenheimer. I don't fucking know. That's dark energy, though.
Wow.
Isn't that fascinating?
So it's
never heard of that before.
I mean, and I imagine what you're talking about, the big rip. It's kind of, I imagine it's on the same time scale as like the sun going out. It's on the billions of years scale, not the,
yes.
It's going to happen in 5.
No, billions, and this is tens of billions of years in the future if it happens.
Right.
Now that's pretty dark and heavy, so let's talk about something that's a little sweet.
Okay.
So speaking of all alone, let's finish out with a palate cleanser and some words from one of my favorite people in the world, Carl Sagan, an astronomer, exobiologist, and turns out a pretty good writer. God damn it.
Yeah, he was.
In 1977, NASA sent 2 capsules into space, Voyager 1 and Voyager 2, and they are the first spacecraft to venture out of the solar system. A team of scientists led by Carl Sagan assembled a sort of message for any extraterrestrial life that encounters those 2 satellites. And it is literally a record carried by a phonograph, and it contains sounds and images that are meant to convey the stories of humanity. So some of the images include the location of our galaxy,
Okay.
our planet's makeup and diameter,
Okay.
basic mathematical definitions so we can actually give directions,
Okay.
the Grand Tetons, diagrams of human anatomy and our DNA, daffodils,
Daffodils.
family photos, Jane Goodall with the chimpanzees, of
Like
course.
photos of Jane Goodall are in the satellite.
In the woods, yeah. The song Dark Was the Night, Cold Was the Ground by Blind Willie Johnson, which I also listened to a lot during my breakup in college.
How did they pick that?
Wordless. That's why. A man eating grapes, a sunset, and a Chinese dinner party. Those are some of the images and sounds
Those are
that
some
were
of the
included
photos
on the
there.
record.
Huh.
Yes. In 2012, the Voyagers officially crossed over into interstellar space, which means they are no longer within the sun's sphere of influence.
So they will just float forever and ever
Yes.
until they hit a gravity pocket or get too close to another solar system.
In about 5 billion years, human beings will either be extinct or we will have evolved into a species completely unrecognizable to us right now. And our sun, which has kept us warm all this time and provided us with light and life, will have bloated into our atmosphere and enveloped the Earth entirely. And there will be nothing left here. Meanwhile, with nothing to erode them in the vacuum of space, or eat them, or burn them alive, the Voyager spacecrafts will continue their journey into the far reaches of space. And this record will outlast even the strongest Maytag dryer, and will carry our memories, and therefore ourselves, into some distant area of the universe, and, in a sense, let us keep living, even after we've been burnt to a crisp. It is essentially a beam emanating from our lighthouse here. We're tapping on the glass, asking if anybody else is home. And maybe they are. Or maybe we are alone in the house. Like everything else, we simply do not know. And that is a very exciting place to be.
I think it is too.
And that was my rabbit void.
I really like that rabbit hole. That was fantastic.
I'm so glad.
I think when I think about the Voyager capsule, some romantic part of my brain thinks like eventually humans will figure out faster than light travel. And when we do that, the universe will finally be open to us in a lot of different ways. And because of that, we'll just go and pick up the capsules and bring them back as like we didn't need you. We got there. We did it. Like we're able to talk for ourselves now instead of somebody just happening upon us.
Well, that's the thing is the Voyager, the Golden Record was not built to just stumble upon someone. It's meant to be found.
Right.
That's the only way it's ever going to be interacted with.
It is truly a message in the bottle in the ocean of the universe.
It is.
Yeah.
Somebody's going to see it in the vast vacuum of space and go, that's not natural.
That doesn't belong there.
What's that? And
Right.
they're going to find a phonograph and a picture of Jane Goodall on it.
Yeah. Since you're talking about the amount of space in space, I want to share with you a fun fact that kind of blew my mind.
Gimme.
And you probably already know this, but
I do know everything.
You do. Are you aware that at its furthest point, the distance between the Earth and the moon, the space in between the Earth and the moon, can fit every single planet in our solar system?
What?
Yeah.
Oh
I'm going to fact check that, but I'm pretty sure I'm saying that correctly.
There's no fucking way.
That's exactly how I felt, and I'm pretty sure that's exactly the truth. We're going to pause and I'm going to Google it, and then we're going to get your reaction.
Oh my God.
Okay, I Googled it really quick. You ready?
I'm ready.
Yes, the planets of our solar system, excluding the sun, could fit within the distance between the Earth and the moon. You know how far that is?
I'm just thinking of Saturn's rings alone.
I know it.
Sweet baby Jesus.
Well, and that makes the Apollo mission so much more impressive.
Oh my God.
Can you
I can't
imagine?
believe we've ever gotten out of here.
Incredible.
I can't believe it.
Well, Lindsey, thank you so much for that rabbit hole.
Thank you so much for listening to me.
I had a great time listening to you.
I'm so glad.
And I learned a lot of new stuff. And then hopefully you did too.
I'm Lindsey.
And I'm Connor.
And I told you this would be interesting.
Thank you so much for joining us. And we'll be back next week with my episode, hopefully.
Indeed, a Rooney. We'll see you next week, everybody.
And I'll see you in 5 seconds.
Exactly. That's my line. What am I supposed to say?
Bye, everybody.
Subscribe.